Good evening, it's Mrs. Bowen with the University of West Florida, and we are solving problem number 18 of discrete random variables on our homework. Had several students send me a text or an email requesting that I solve this problem. So here we go. So it says, if x is a binomial random variable, compute the probability of x for each of the following cases. So in each case, we have multiple ways of solving this problem. Okay, I'm going to go over the two simplest ways first, as well as how you would calculate the expected value, the standard deviation, and the variance. And then I will go over the more challenging way. All three ways that I present are valid and will get you to the correct answer. And you get to choose often which method is best for you and what you like best. And typically I encourage you to do whichever one you make the least errors on. Okay, so let's get busy. So, oh shoot, I forgot to take out my answers. I often forget to do that before I start the video, and I'm sorry about that. Close your eyes, don't look. We don't know the answers. Okay, so here we go. We're starting from scratch. It says if x is a binomial random variable, compute probability of x for each of the following cases. Part A. What's the probability that x is less than or equal to 2, given that n is equal to 3 and p is equal to 0.4? Okay, so that n is equal to 3 and p is 0.4. So the two fastest ways of solving this are, let's bring up my notebook paper here. So here we go. So we have that n is equal to 3 and p was equal to 0.4, and we have that we're looking for the probability that x is less than or equal to 2. Okay, so we have a couple of different ways of solving this. The first thing you need to look at is the fact that we have our sample space. Sample space only has 3 or 4 possibilities. We could have 0 chosen, we could have 1, we could have 2, we could have 3. That's it. Those are the 4 possible options. Okay, we could have 0 successes, 1 success, 2 success, or 3 successes. And since our sample size, or the number of trials we're going to repeat, is only 3, we can't have more than 3 successes, and we can always have a 0 success. So that's how we end up with our 4 options. So we know that if we were to take the probability that x is equal to 0, and we add to that the probability that x is equal to 1, and we add to that the probability that x is equal to 2, and we add to that the probability that x is equal to 3, that must sum to 1.0, because we have just added the probability associated with each possible outcome for our experiment. We've summed those probabilities together, and we know by definition that those probabilities must sum to 1. So we can say that the probability that x is less than or equal to 2 is equal to the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. Or we can say that the probability that x is less than or equal to 2 can also be equal to 1 minus the probability that x equals 3. Okay, so let's ponder that for a moment. If we know that the probability of every single one of these potential outcomes, the probability associated with all of these equals 1.0. If we know that for a fact, then what we can literally do is we can say that what I'm looking for is the probability that x is less than 2. So I'm looking for the probability of these all summed together. So the only thing I don't want in that probability is x equals 3. So if I move it over here, I have 1 then minus the probability that x equals 3. Okay, and then that gives me what's left over here on the left-hand side of the equation. Simple algebra. Okay, so that's what I have done right here. So I can either add those three probabilities together, or calculate one and subtract it from my total probability of 1. Let's solve this both ways. So the first one is that we're going to take each individual probability and we're going to add them together. So how do I find out what is the probability that x equals 0? And what is the probability that x equals 1? And oops, I'm still in Magic Ink. Hold on, let me get out of Magic Ink. Sorry about that. Let me turn that off. I'm going to have to use my... Oh, I think I've got it turned off now. So let's try that again. So this would be, what is the probability that x equals 0? What's the probability that x equals 1? What's the probability that x equals 2? We need to solve all of those. Well, remember, we are dealing with a binomial where the probability of success is 4, and the probability, or I'm sorry, our sample size is 3. So we have n is equal to, 3, and our probability of success is 0.4. Alrighty, so in this case, we can bring up our tables, and our tables are right here. And I can say that my sample size, or my trials, the number of trials, is 3 right there. And our probability is right here at 0.4. So we're going to be looking at the intersection, and we know then that we're going to be looking at the probability that x equals 0, plus the probability that x equals 1, plus the probability that x equals 2. So we're going to sum those three probabilities together. So that's 0.216. Where's my paper here? So 0 is equal to, oops, let's go back to the different color equal, 0.216. And then let's go back to our table, and x equals 1. So that is, as long as I'm on the right column, it looks like I am, 0.432. So probability that x equals 1 is 0.432. And then we have the probability that x equals 2. Let's go back over here. And that is equal to 0.288. That's right there, 0.288. So we'll come write that down. So probability that x equals 2 is 0.288. So then I can say that the probability that x is less than or equal to 2 is equal to 0.216 plus 0.432 plus 0.288. And I can grab my handy dandy calculator. Uh-oh, I left that out in the car. I'm going to pause the video and find my calculator. Hold on, guys. Okay, so I found my calculator and I added 0.216 plus 0.432 plus 0.288, added all that together, and I got 0.936. So now we're going to switch gears and we're going to put this in, let's see here, in 0.936. So 0.936. We're going to check our work and see if it likes our answers. Yep, been logged out too long looking for that calculator, and we got the correct answer. Okay, now remember, I promised you that there was another way of solving this. So let's go ahead and show you the other way of solving this. Let's go ahead and do the other where it's 1 minus or 1 minus the probability of x equals 3. So let's switch gears to switch pen colors. So we have probability that x is less than or equal to 2 is also equal to 1 minus the probability that x equals 3. So we only have to look up one probability. Let's switch over to our chart. And so we have right here, n is right here. So this is my n. That's n equals 3. Here's my probability. Whoops. Here's my probability right up here. And there's 0.4. So now we're going to come in at 0.32 where x or r equals 3, which is right here. And we're going to come over under the column of 0.4, and we're going to be looking for this number right here, which is 0.064. So 0.064. So this is going to be 1 minus 0.064, because the probability that we have 3 successes out of 3 is 0.064. So we're going to go 1 minus 0.064, and that is equal to 0.936. Notice we got the exact same answer right there and there. Okay, so 2 different ways of calculating that. I'm going to show you another way to calculate this. Okay, so if you didn't have a table handy, we could have said, oh my, I need to use the binomial formula. So let's use the binomial formula, and what I really want to calculate using the binomial formula, all 3 of these probabilities, not really, I could, but on an exam in particular, I don't really have time to do that. So you need to think about the fastest way to solve problems, and on an exam, if you only have to calculate one probability using the binomial, that's going to save you a lot of time, and that's going to be the best option. So let's show you how you would use the binomial for calculating the binomial formula for solving this problem. So if we said we wanted to know what's the probability of x is less than or equal to 2, I could say that that's 1 minus the probability that x is equal to 3. Now I need to solve what is the probability that x is equal to 3. Well, our n, well, let me not write there because that's going to be space I'm going to use in a moment. So we'll say n is equal to 3, and our x is equal to 3. So we're going to have 3 trials. We're going to have 3 successes. The probability of a success is equal to 0.4. The probability of a failure is equal to 1 minus p, which is equal to 1 minus 0.4. So that is equal to 0.6. So now looking at our binomial formula again is n choose x times p to the x times q to the n minus x. So how many trials do we have? 3. How many successes do we have? 3. What's the probability of a success? 0.4. How many successes am I going to have? 3. What's the probability of a failure? 0.6. How many failures am I going to have? Total number of trials minus my total number of successes, which is equal to 0. Okay, that's how the formula works. Now, 3 choose 3, 3 choose 3 is equal to 3 factorial divided by 3 factorial times 3 minus 3 factorial. So that is 3 factorial divided by 3 factorial times 0 factorial. Remember that 0 factorial by definition is equal to 1. Okay, so you need to remember that. Alrighty, so this is going to mean that we have 3 factorial factors out 3 factorial, and we are left with 1 divided by 1, which is simply 1. Okay? Let's also recognize the fact that anything raised to the 0 power is 1. So if we have this 0.6 raised to the 0 power, that is really just 1. So what do we have left of our formula? We really have 1 times 0.4 cubed times 1. That's all we have left. So really all we're solving for is what's 0.4 raised to the 3rd power. So I'm going to punch that in my calculator, and I find out that that is equal to 0.064. Well, isn't that what we calculated earlier right here? Yes, it is. Okay, so right here we have the exact same probability. So that's how we calculated it mathematically. So let's go ahead and write that in. And so we know that the probability that x is less than or equal to 2 is equal to 1 minus 0.064. we simply can change a sign on that and add 1, and we find out that the probability then of finding that we have 0, 1, 2, or 0, 1, or 2 successes is equal to 0.936. How easy is that? Pretty easy, isn't it? Okay, so we've discussed 2 ways of solving this. Now, in addition, I said I wanted to take and go over how we calculate the mean, the standard deviation, and the variance. My computer's getting hot, so that's why my handwriting looks so bad right up here. It's just the fact that my computer is not processing everything properly because of the heat. I ordered a cooling pad, but it did not do the job. It broke within a moment of using it, and so I had to send it back. So I've got to get another one. So we'll try writing this again. Let's see if I can get this to work right. So the mean for a binomial is equal to, remember we're going to write it down as mu, and that is equal to NP. Okay, I promise that's not my handwriting, guys. Okay, and N was equal to 3. The probability of a success was 0.4. So you're simply going to go 3 times 0.4, and that is equal to 1.2. Okay, so the expected value for this binomial distribution is 1.2. In addition, if I wanted to calculate the variance, oh boy, let me try this again. I need to get my computer cooled off. It's not doing much of anything right now. Okay, well, we're just going to have to hit the eraser here. There we go. Okay, so let's try this again and see if we can get this to write nicer. The variance. There we go, that's a little bit better. Which is equal to sigma squared is equal to my favorite formula in all of statistics, NPQ. So that's going to be equal to 3 times 0.4 times 0.6. And so that is going to be equal to 0.72. 0.72. So you go 3 times 0.4 times 0.6, and that's 0.72. Now if we want to know what the standard deviation is, so we have the standard deviation. That is simply sigma, which is the square root of NPQ. And so the square root of 0.72 is 0.8485. 8485. Alrighty, so that's how we calculate the expected value, or the mean, the variance, and the standard deviation. Was that asked on this homework problem? Nope, but we do have an exam Tuesday. Just letting you know, you may want to make sure you remember how to do this. Alrighty, so let's go back to our homework problem. Oh yes, I promised you one other way of solving this. Now, if you have the TI-84, oops, let me get that up and running. Okay, if you have the TI-84, it's important to realize that we can do a couple of different probabilities with the TI-84 when it comes to the binomial. We can do, we can calculate the binomial for specific values. So if I have the binomial distribution, okay, that's the key. But the binomial distribution, if I want to find the probability of a specific or specific x, okay, then I'm going to be using what's called the binom PDF distribution, or function on your TI-84. If I need to find out what's the probability that x is less than or equal to a specific value, I'm going to use the binom CDF. the C stands for cumulative. So what that means is you have to pay attention to the fact that in my definition right here, I have equal. It's less than, and equal to. Those are the two important parts here, okay? It has to be less than and it has to be equal to if you're using the distribution with that C right there, okay? With that C. The binome CDF, because that stands for cumulative. Cumulative means everything, we're going to start from the beginning and we're going to add everything to the point that we've identified. So we're going to start at the lowest bottom point and we're going to add all the way up to whatever that specific value is. We're just going to add all the probabilities up to that specific value and including that specific value, okay? Not stopping at the value before, but it includes that specific value. So when you look at our question here, we were asked to find the probability that x is less than or equal to 2. So that means we want to know what's the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x equals 2. Okay, so we're going to be adding all those up. We're going to include the value 2 and everything before that. So in this case, it would be very appropriate to use the binome CDF. So we're going to bring up our calculator here, and we're going to click the second button right here, and then we're going to come to the VARS, and we're going to click that. Then we're going to scroll on down until we see the binome CDF, which is right there. You see that's binome CDF. C is cumulative. So that's the one I want. And so I'm going to hit enter. So that selects it. It says, how many trials do I have? Well, remember, we have 3 trials. And it says, what is the probability of a success? And we're going to click that on down. And the probability of a success is 0.4. And then we're going to go down one more. It says, how many x's and less do we want? So when we're looking at the CDF, it's asking, what is the value of x and all the ones below it that we want to know the probability of? So that's going to be 2. And then we're going to hit enter 3 times. Yours may not be 3, but that's what it is for me. And you can see it's equal to 0.936. Now, isn't that the exact same thing that we calculated earlier? So, whoops. So that is 0.936. So that is equal to 0.936. Now, if I had wanted to, I could have gone ahead and continued and said, oh, I want to know what's the probability. Oops. What's the probability that x is less than or equal to 2? And I could have said, oh, I know for a fact that that's equal to 1 minus the probability that x equals 3. And I can use my TI-84 to help me with that one too, okay? And here's how I can do that, because I have a very specific value. And what did I write right here? I said, right here, if it's for a specific value, then I'm going to be using the function with the p in it, okay? So very specific x. Well, this happens to be a very specific x, doesn't it? Okay, so let's use the other function and show how this works. So we're going to come in here, and let me hit that right there, and bring up our TI-84. We're going to clear it out. And you can do this all in one shot. You don't actually have to calculate. You don't have to break this up into steps. You can simply go 1 minus, because that's how we're reading it. And now I can say what I want to subtract off of 1. So I'm going to subtract off the binomial. So it's going to be second and then vars. We're going to scroll down until we get to the binome PDF, which is right here. I'm going to select it by hitting enter. How many trials do I have? 3. What's my value or probability of success? 0.4. And in this case, what is the specific probability or the specific x that I want to know the probability of? In this case, it is 3. Now remember, I've already gone 1 minus, because I've already put in the calculator 1 minus whatever I'm calculating. It will give me the final answer of what is the probability that x is less than or equal to 2. Okay, so I'm doing that in one step. I hit enter probably 3 times. And there you go, 0.936. So 0.936. 6. So that is another way of solving that exact same question. All right, let's move on to the rest of the problem and we'll solve it quickly. So it says right here, what's the probability that x is greater than 4, where n is equal to 6 and p is equal to 0.2? So I'm going to use the tables to solve this one. So we have x is greater than 4, n is 6 and 0.2. So let me come over here. So we say that n is equal to 6. P was equal to, P was equal to 0.2, and we're looking for the probability that x is greater than 4. So in this case, that is going to be equal to the probability that x is equal to 5, plus the probability that x is equal to 6. And I'm going to look those up in a chart because my probability of is a multiple of 5, 0.05. Okay, so it's 0.2, so that works. And I'm going to come in here and look at my chart. And we had P is equal to, or I'm sorry, N is equal to 6. And we needed to find the probability of X is equal to 5, which is also known as R on the table here, and 6. So we're going to come over here to where P is 0.2, looking at the intersection. And I'm going to come right down here. And I have of 5 is 0.002, and of 6 is 0. So 0.002, 0.002 plus 0.000, so that is 0.002. So what's the probability that x is greater than 4? 0.002. So we'll check that one real quick. 0.002. We're going to check our answers. And we got that one right. Now it says, what about if the probability that x is less than 5 when n equals 9 and the probability is equal to 0.8? So that is going to be, let's see here. So x is less than 5, n is 9, and then we have 0.8. So n is equal to 9, p is equal to 0.8, and we're looking for the probability that x is less than, my memory was short, sorry guys, 5. So x is less than 5. Well, I'm going to use the TI-84 on this one. You could use the tables, but I'm going to go ahead and save some time, and I'm going to demonstrate how we would use the TI-84 for this one. So this, because the TI-84, remember, has to be equal to, I'm going to rewrite this because this is the same thing, that x is less than or equal to 4. And I must have that equal sign and less than sign if I'm going to be using the TI-84. And I'm going to bring it on up. Let's see here, right over here. We'll scoot it on over here. Oops, did I scoot it over too fast? Please move over. All the way, thank you. Okay, so I'm going to hit clear, and I'm going to go vars, and I'm going to scroll down to binom CDF, because I need the cumulative. I need the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4. I need all of those added together. I'm going to let the TI-84 do the work. I have 9 trials. I have a probability of success of 0.8, which is very high. And then I'm going to do 4 trials and less and sum those together. And I'm going to stick that in my computer, and it's 0.01958. Now that 58 is going to round up to a 6. So I'm going to put down is equal to 0.0196. So 0.0196. So let's come on over here and put this in our answer. 0.0196, and we will check our answer. Very good. And then the last one is we have the probability that x is greater than 1, where n is equal to 7, and, or greater or equal to 1, and then n is equal to 7, and the probability is equal to 2. We can use the tables, or we can use the binomial formula. Let's go ahead and use the tables on this one. So let's see here. So it's 1 and 7. So we're looking for the probability that x is greater or equal to 1. n is equal to 7, and I think p was equal to 0.2, but I'm about to go back and double check that because I don't want to make a mistake. Yes, it is. Okay, so the fastest way of solving this one here is, remember, that the probability that x is greater or equal to 1 is really equal to the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4 plus the probability that x is equal to 5 plus the probability that x is equal to 6 plus the probability that x is equal to 7. It's all of those added together. And I can do that because I'm going to be looking them up in the chart, and that would be fast and easy. But I'm on a test, and I want to take and just save my time because my time is valuable. So I am smart enough to know that this is the same thing as saying that the probability that x is greater or equal to 1 is equal to 1 minus the probability that x equals what? Take a guess. 0. Correct. Okay. So all I have to do now is look up one probability and I'm done. So it's 1 minus, now let's look at, so we have n is equal to 7 and p is equal to 2, and we're going to look up a probability that x is equal to 0. So let's look that up. So we're going to come down here. Here's my n. And we're going to come down and find n is 7. And our p is 0.2. Whoops. Sorry. I highlighted way too much. Is 0.2. And we're going to come in, we're 0, or x or r in this case, as it's titled in here, is equal to 0. And we're going to come down, we're going to look at the intersection, and there we have it. So the probability that x equals 0 is 0.21. 0.21. So 0. Oops. Let me go back and glance at that one more time on my decimal place. Yep, okay. So 210. So we're going to put that in our handy dandy calculator, and we simply say 1 minus 0.21 is equal to 0.79. So 0.07, oops, 790. Okay, let's go put that in our solution here and see if we get another correct answer. 0.79. Check answer, and we got all of our problems right. We reviewed how to calculate the expected value, the standard deviation, and the mean, and we have shown how to calculate the binomial using the tables as well as the TI-84. And if you have any questions on this, send me an email. Look forward to hearing from you.